my last video, I had different ideas in mind about what to come next, what video to do in the future. Even some higher level algorithm tricks that are nicer and simpler to explain, so I hope they will be shorter. I wasn't going to dive deep now into assembly, and especially the madness of the generated code from compilers and the whole argument about compilers versus assembly, but I will make an exception as I had some things to get out of my chest and I need to do this video, and maybe there will be more videos like this sometimes. A bit more ranty, but showing some code, but a mix of that. And sometimes I get too excited, or maybe spark a bit, you know, because I let's say mentally masturbate around certain subjects, and I obsessed, and I am at home alone, walking around the sofa and ranting about things with passion. Maybe I read something on the internet that nagged me, and I might not entirely disagree with some things I read, but I get into actually mode. And I need to read some random thing, and from a calm state to be in a not exactly fanatical state, maybe some crazy state where I'm lost for half an hour with my thoughts and my loud thoughts, because I might be talking to myself and ranting in the air, or writing long posts on YouTube or something. And there was this discussion, and there were more discussions about whether compilers are smarter than you, and you shouldn't even try to optimize, or not write anything in assembly, or not even confuse the compiler. Let the compiler do its work, and follow the modern programming standards, because if you do this, the compiler will optimize, and we have faith in that. We are gonna nag you without even checking that, hey, you should do things like this and not like that, because it's both more clear and better for the compiler. But we don't check because we like to not have to check, to not be surprised, and we like that things are certain. We like that we have to write things in a high level and we don't have to look back anymore. Because if you look back, if you look into the compiler generated code, as they say, the compiler looks back at you. The abyss stares back at you. If you look at the abyss. The abyss, not the abyss. And I had a fit about this, because I wasn't disagreeing that, someone said it's a misconception that if you write everything in assembly, the code will be faster. And I agree actually with that, because someone can write bad code in assembly, and I could write something in QBasic and I could make something faster than his assembly code. You need to know what you do. But then this discussion continued into the compiler is so smart, is going to, if you worked for a week trying to optimize manually in assembly, then you will waste your time and maybe get a 10%, 5% of improvement, or even write code that is worse than what the compiler produces. You will waste your time. Okay, you will make for a 5%, so what? But I already have examples where I'm trying to make the C compiler, the DJGPP even, it's producing something that is half the speed, or even 3 times the speed slower than a very optimized Rotozoomer in assembly I've written. And then I try to help the compiler. I see the generated code, I change some things. I try to help the compiler to produce something more. I try different ways for my Rotozoomer. I have a one that writes 16 bits on the screen, one 8-bit. I say, okay, we are going for the 8-bit because it's simpler. It doesn't have to get low and high byte and connect, and something that the compiler has to do with shifts, but I do it in another way. I'm trying, and even that, we will see. That's the point. I'm going to show you some optimized Rotozoomer, which I want to use also for a future video, because we will expand to some cheating ways to make it faster. That's a different subject, by the way, how in the demos in some of the effects are insane cheats. They don't work with generic data. And anyway, but in this run I'm going to show you that. So you will also see some code and how much I optimize it compared to the C, but we also see some different generated code. We will discuss about various generated code. I found something. There are some things that help the compiler, but I couldn't prove the point that, hey, if you help the compiler, you don't need to write the assembly. You're gonna reach the same speed. And if you are going to put so much effort, why not just write it in assembly? If you're going to put so much effort to prove that we don't need this anymore, this is a thing of the past, we just need to let the compiler do things for us and we don't have to think. And it's wrong that you even started writing, it's useless. And I had more stuff to say. I wrote a lot of stuff, but I'm not even talking about that stuff. There are so many things. I was inventing words, I was inventing a concept called the programmer's evasion, but I invented it just right now as I was writing the script. I was thinking of terms, the pessimization that Jonathan Blow mentioned, but that might be older. And I thought of the pessimize optimize spectrum. I want to make some theoretical rant about it. I could make some episode that I'm not showing, because I want to get that out of my mind. It's gonna be a mix. And then I was re-examining yesterday or before. I had to sit in my couch and think about things. Because I have this mental masturbation with minuscule. It's not even minuscule. It's like going beyond where anyone else. When people finish some algorithm, say that it's good enough. Let's move on. Let's produce something, and that's the right approach, because they will end up producing the product. I will mentally masturbate. I've said it 3 times with the concept. But I like when some people do that, because that's how you get some out of the box ideas, which can be useful some way. Yeah, I was writing about the quote from Knuth about the premature optimization is pure evil or something, and people misuse this quote where they want to avoid the programmers. I want to avoid to have to do old school coding, you know. And part of his code wasn't about don't optimize, but don't optimize the 97% of the code. And this is what I don't do here. This is I optimize the 3%. All these demo effects, they are brute force effects, and there is a core that if you optimize the core pixel rendering, calculation of effect and everything, then you got the. It's not some big project where the performance is more spread around. So they could see you and see, oh, that's pretty much optimization, because you take the time to do it, but they will misuse the code, because I'm doing what Knuth told us to do, like optimize that 3%. That is the critical loop. And I'm not always doing. I have projects where they are not optimized, because I also wanted to produce something. I have demos where half of the effects are very optimized and the other could be better, but I have to add fillers of effects. And I guess that's the point of my channel. There are a lot of theoretical ideas. There are a lot of programming dogmas I don't like, and they restrict you. They are like, don't do certain things anymore, because some things are things of the past, and we should better forget them. You know, that's why people say you don't need to unroll, or you don't need to do this or that, or you don't need to write things in assembly, or even you have to split your routines, because actually I noticed something. It can be true sometimes, but it's unpredictable. Those are not wrong exactly, but the people are throwing them as dogmas because they don't want to even try doing that. And they say, because I didn't do this and I do the modern programming principles, and because of the compilers, my code will always run faster. But have you tested it? Sometimes you do the old stuff and it's faster. Sometimes it's slower. And they might say, you confuse the compiler. Don't confuse the compiler. Yeah, but the same compiler, in one algorithm I can do this principle, and the other algorithm, the other principle, and one will be slow, fast, slow. It's unpredictable. It's not that if I follow this thing, things will be always faster. But people just don't want to bother. This is the programmer's evasion. Okay. And maybe they are bothered that some people spend so much focus on that, or maybe not. Maybe they are feeling uneasy. I don't know. And but I have gone now too far. You see, I started with that, and there are millions of things coming in my mind. I have a script, I have a run that has nothing to do with what I said now. I scripted the things I will say for this, but it has nothing to do. And maybe we can speak about this thing in the future, and I'm fine. You know, I'm fine about ranting. Whoever wants to hear my rant, maybe some people are inspired by the rant, maybe some people are bored. You can skip and go to the next one. I think Optimosophy will be like this sometimes, or many times. It will reflect. It will show you the tricks. Some episodes will show some modern algorithm tricks that I find interesting. Not standard, not so standard stuff, but some more wild ideas that one could maybe in one or another way apply to his projects. And so there is material, even for someone who doesn't want to dwell too low level and mentally masturbate with assembly. And some of the other stuff will go into some low level tricks. Retro demo effects in various platforms. Even I could do videos explaining other people's effects, like how the scaling in Batman Forever on the Amstrad CPC happens. This is interesting. A lot of things are interesting, or some other stuff. And sometimes some episodes will be ranty. Maybe I will not even show how to optimize an effect, but I will try random things, or I don't know, generated code on silly things. Because maybe Optimosophy is not about optimize. Optimosophy is about the limitlessness of the human mind. Because the compiler is a machine. The compiler is a robot that uses some gimmicky tricks, automated, and to find heuristically some more stuff it can do here and there. And you say it's not so easy, it's very clever, it does even more than you think. Yeah, but it still does specific things. It has a limit. The human mind is limitless. This little video will be my adventures into my having a fit about whether the compiler optimizes for you, or if you are smarter than the compiler, or if you are not. If you don't even bother, because it will always be smarter than you. And I was just trying some of my old code. I was looking at Godbold here. Maybe I have some of my old stuff. Okay, that could do. And I was trying both C versions of the Rotozoomer and my assembly version. Of course, my assembly version is just a big bunch of unroll, but it's not the unrolling, it's something else that makes it faster. And the issue is, yeah, about the unroll, I haven't found some macro in this format that can help me copy this many times. I have heard some solutions when I was asking at Puet, but I need to try one solution that I have to change something with my jump at the end of this block, where I jump back in the beginning. And so it all started when I started comparing various C and assembly version of the Rotozoomer, and I noticed, of course I was first compiling in Watcom. I noticed that while in my assembly code, and that's something I learned from Z80, I'm trying, and you don't see that very frequently. I'm trying to, in the inner loop, to just have registers, unless I need to read it from memory. If I don't need to read from memory, I shouldn't be using the memory. And maybe I should fight with the limited register of the x86. And so here the inner loop, everything is register. This is the very optimized assembly soup. Now, as I said, I don't have macros, so this seems grotesque. This is for the whole Rotozoomer line, and because it's for the whole Rotozoomer line, see, there is only a jump rotation psi, rotation y. Sorry, I call psi y. What can I do? It's from Greek math, and which doesn't make sense. And also the way I wrote it, I do stos w. I write 2 pixels at once, but I calculate each pixel separately. So when you see 2 adds, and these are registers that are preloaded, and I have the exact, these are like add, no, these are the interpolants, and I managed to fit everything in. Bx, dx is uv, si6 is the udv, and there are no, so I'm using bx, cx, dx, these are preloaded and I never push them around. You need ax to stos w, and what I do is when I calculate the u and v interpolants, this is a XOR texture by the way, so I'm moving b8, the high byte of bx, to first to al, and I XOR al with dh. So I always b8 XOR dh. That means u XOR v. But these are 8-8 fixed point. This works very well on a 286. It's very fitting. I mean, it works everywhere, but I mean, I coded this for 286, not 386. But this representation is great because you don't need to shift. You will do your calculation, and at the end, high byte bx u high b8. At the end, you would normally give me b8 shift 8, and to get back the dx to get back the u and v, the original, not the fixed point versions that are 16-bit 88, but the original. So I have arranged everything this way that in the beginning I do the adds later, the increment to the next one. I increase u plus cu, du and v plus dv, and then I just get things on al or no, I get the u and XOR it with the v. On al, on ah, everything fits. No extra shifts, no rearrangement, shifts or, and so on. And it's ready and I just store it. So this thing that's interpolates the UVs for 2 pixels in the Rotozoomer. The vectors are, everything is prepared beforehand. Okay. And writes the results directly on AL, AH and stores 2 bytes. It's as fast as you can get it this way. But there are some future tricks one can do. There is more, but this was my thing that managed to get in 320 by 200 on a 286 at 20 megahertz. I was hitting 17 frames per second, which is a little, but it's a 286, man. On the 386 I hit 35 frames per second. And there is also the bottleneck of the video RAM. So I was trying various C functions, and I'll tell you. Sorry about that. Down here, this is the one that, as I say, it writes 2 pixels at one, and it takes an advantage that if you read the B8s and D8, if you read the high bytes of a 16-bit register, it's like you shifted it on the right. This is something the compilers, I don't see them doing, or they struggle to do it. If you make a shift right by 8, they don't do it. Maybe they do it sometimes, I don't know. So I have also written, here I have written the 8-bit version, I STOS B, I calculate once on AL, always STOS B. Just to be fair, just to compare with the compiler. And because when you write on the compiler, I don't know if I might have it here. I tried various things. Damn, where is it? I might not have it anymore, unfortunately. This is the copy. I had a version where the C code would merge 2 bytes together and make the 16-bit pair, but that would create horrible code. So I said, okay, fair enough. I will compare with a byte version. This is a, yeah, I don't do any tricks to do 2 pixels at one. We might try that later. And I try to make a very, very simple, the most simple. I had some for next, I changed them to while. In this case, I might have noticed if I put the while below, although it doesn't make sense, it might produce a bit better, a bit faster code. If I put it above, if now like it is, this goes after my performance tests, which some people will say, wouldn't that be below because the check happens at the end and you don't do the unnecessary check, or maybe if the check fails it has to jump down, there is a jump from down to up and then the check and then another. I don't know, man. I don't know. This is not predictable. People say, yeah, help the compiler to optimize. Now, after a lot of rearrangement, I think I found the most optimal so far. And I would also do anything I can make into constant. I mean, this could be already const because they are arguments from the. It's a bit vague how it works. So, but anyway, I still did it here just to be sure. And there was no difference. But here is very tight. I don't unroll, so I compare with an assembly function that this is the equivalent. So I had these two, and I compare it with a function. I'm still using the register here. I'm not reading anything from memory. I just say, okay, make a regular loop, and that's it. For some reason, that's not. If you put that, it's not a comment. It will still compile. You have to put. You will think it's a comment, but we don't want. I use EBP here, so I have to push it. I use EBP to so that I release. What was I adding before? I was adding CX, and now CX can be my loop. Man, x86 is very tight with the register. I hate it. I tried some more stuff. ARM is much better. So, to be fair, I made this with this one too. And here, this one, it says as tight as it gets. It's fixed 0.8 bits. So I shift right by 8, but I don't think it sees that. And I had the produced assembly. Of course, that's Watcom. It's not that bad. Where is the inner loop? I have seen worse inner loops. This is the inner loop. And you see, some things are happening in register. It does a shift arithmetic right by it. Now there is another thing. It uses the 32-bit registers. So how will it, even if I told it use the 16-bit, the sign integers, in hope that it will understand and put things in the 16-bit and get the high byte of the register without needing to save. You might say that's the same. What's the difference between this command and that command? Oh, but and it does the XOR directly, I see. It doesn't need to put it on AX or something. But it has to shift both of them. That's something I should. You have to put one in AX to not disturb. Yeah, you are disturbing. Hold on a minute. Yeah, oh my god. Move DX. Yeah. It has the DX and the AX. These are two extra moves. From DXAX to EDIECH. It shifts right. I'm not sure, but here, look at the ESPs. Look at the. I call them ESPs now. It's reading variables in the inner loop. It's doing two reads. It might do some extra stuff. How does it? Yeah, no, it never. Now DX and AX. Where are they added? It adds to EDX and EAX. This is the U and V. It adds the DU and DV, which are added directly from memory variables instead of using registers. And it just has to move them to EDI-ECX so that it shifts, because if you shift directly the U and V, you are destroying them. You cannot shift the DXAX, but you could get the high byte normally and put it somewhere else. And you could, I don't have the DX and the AX, therefore. You can rearrange stuff, and it writes bytes, yeah. So there are some things that are more unoptimal. That's the thing. Okay. Now we were testing. Forget about this part down. This goes for the high resolution because we unroll. We unroll our assembly, and you have to unroll different width. And yeah, I know it's a pain. You might say, why do you even bother? And we need this 256 for the 8-bit version. Maybe it works. So we are running on a 486, but that's... So I don't have a... This is the old frame. I don't have a frame counter here, but I have here 28 frames. And if you run the assembly version... Ah, no, that's not the assembly version. I store the assembly version here. It runs definitely much better. 23 frames to 52. See, there is a big difference. Now, to my surprise, I went to Godbolt because I didn't have that project at that time on with the DJGPP makefile. I could have added and tested at the time. I did it later. So I went and I ran it. Yeah, Watcom doesn't do it well. Let's see how DJGPP does it. And that's the 1 byte version with the shifts. Oh, and to my surprise, you know, it's quite better. Add EBX EDI, add EDX EBP. That sounds very similar to me. That's the U and V. I was running, you know, I was like, compilers doesn't do better. And then, I was like, no, that proves their case. I'm losing here. Okay, and I was surprised. And that's a small loop though. If you write bigger things, it's harder. But so I still have a counter argument. But it's interesting because it's even using EDI and EBP. Can I see? Let's see, not this one, but oh god. I need to find this thing with the macros. Add BXSI. Yeah, it uses a bit different register. EAX, EDX, EBP, EDI. It even uses the BP. It must be pushing the BP somewhere. It pushes the BP and a lot of other stuff. Because if you don't push it, you have issues. Oh, it even switched using ESP for the arguments, while Watcom will use EBP for the... Will it? Ah no, it's using ESP too. There is another Watcom code that it would push the ESP and use EBP. It would store the, not push, store the ESP to the EBP and use EBP for the argument. There is some other code. See, compilers are unpredictable and I don't know. But I was surprised. It even seems, look, it even seems to, it does it actually. It moves B8 high and D8 high. The high values of the, oh my god. It adds EBH, EDI, EDH, EBP. And these are fixed 0.88. And so it, okay, it does it. It does move the high bytes to EAX and ESI. It XORs the EAX and it writes the AL. Now it doesn't do stores, but maybe this is faster to move. It depends on the processor. You know, in some cases stores is slower, in some it's... Oh, I can't believe it! And I was like, whoa. So what? And I was like, okay. These are the ones that it adds. These are the U and V adds, I think. So it even can detect. So if you were to say, okay, shift by 9, and that makes sense. Okay, things will change a bit. It will have to do the shifts. But if you do shift by 8, it can be clever enough to... I thought it didn't. But here is my surprise. My surprise was like, oh, so now we managed to do the compiler, but only for this case, for the 1 byte. Not the one where you try to combine 2 bytes in once. Actually, no, yeah, exactly. So if we unroll it, because if we unroll many times, we have the equivalent of this one. Move BS, XOR BS, move. Oh, I'm still, it does 2 moves. You see, that's the thing. I move BH to HL, the high U, let's say, and I XOR directly with the high V, without even moving. Okay, so I'm still a bit better. But at least it's close. Now this one moves both of them in some other ways, XOR them together. It would have said move AL to BH and XOR AL with DH. See, I'm still doing better. And then do the add to it. Does with 32 bits, even if it's these are ints. Unless if the there might be some micro rules that if you add the 32 bits instead of 16 bits, it might be better for the cycles or something. I don't know. But it doesn't seem to, because maybe I should try on a real PC. I tried sometimes. So I'm still one step ahead. But anyway, I'm like, can I now recreate this unroll? If I take this and repeat it a few times, shouldn't it be... I think I need to do that too. Or, okay, I even did it. Let's do it simple. I'm like, okay, where is it? What? Which? I cannot even highlight. I don't even... Oh, it's here. Is it? Okay, it's here. It does it here. Move BHDH. What? I unrolled the same thing and it destroyed it. Sometimes it does it, sometimes... What is this? ESPs! ESPs everywhere! Damn, just... And there's the other. If I wanted to unroll, I would have to... You can be clever and you can say, you know what? If I know that I'm unrolling 8 times, you do that, and if your width is 320, for example, this should work. Where is it? Compiler soup. Yes. Where are the ads? Lee. If I see bracket, it's not always. The Lee is not necessary. I mean, you don't know if it's fast until you run it, but I did it. Okay, maybe without the loops. You can't follow anymore. It's reading ESPs. hard to see. It does move a S6 DHBH, but I'm more clever. I'm more clever than the compiler. You do it like this, and it's beautiful. It's beautiful, but now I noticed. Move A6 CAX BH DH, XOR them together, and I'm like, move BH to AL, XOR immediately. Okay, one less. This is 5 lines. This is, I guess, why does it increase E6 to do E6 minus 1? And you might say, people say, it does something you don't understand. It's compiler thing. It's going to be faster than you will ever be. Don't question the God. Why are you questioning the compiler, godchild? No. No. And if we want to be more fair, I transfer the code on the DJGPP framework. I call it Optimad1 here. And I think I tried various things. I need to see here. I'm not trying the assembly. The assembly is on the other side. It's only Watcom. Although I should learn one day how to write assembly for both. And let's see. I do the shift by 8 to help the compiler, and only DJGPP is clever enough. I mean, DJGPP is pretty clever sometimes, and I have seen some vast improvements compared to Watcom sometimes. But compilers are so unpredictable. I cannot say, hey, now DJGPP is my god, and I will. It's not. I'm not saying you should write everything in assembly, but if I decide to write something in assembly and there is this idea that this is a thing of you don't need to do this anymore. We have solved it. We have not solved it, and it's better we have not solved it because I don't want the robots to make my work. We lose? It's like I thought of another thing. It's like Kasparov playing with Deep Blue and say, okay, Deep Blue now can beat the humans in chess. You should not play chess anymore. Okay. You should know the human spirit is destroyed. Okay, and let's go back. So, and this is Optimosophy. This is going to be crazy as that. Sometimes, many times. Let's go and see. I even have an unroll macro so that I don't copy. Ah, God. And people say, why are you unrolling 320 times? To be fair, compared to the assembly version, which if I unroll, I have one less register. It's not just, oh, compiler does unrolling for you. This is so generic, man. It does it sometimes. Many times it doesn't do it. And it's doing it in such a clumsy way that, no. You have seen my videos about unrolling magic. Unroll is a special philosophy. It's not a trick. It's not something you say, yeah, compilers do it for you, which they don't. They might do it sometimes. I realized they do it sometimes. It was interesting. So, let's see. I think I'm just ranting here. I promise to not rant, but this is a special episode. You know, I promise to not take hours for something that could be said in minutes. I'm just trying to think here what I wanted to do here. Which version is that? This is the one, I'm even unrolling it. But we should try, just to be fair. And maybe, oh, I think, no, I thought, did it, hold on, which version is that? Is it the right, it must be the right one. Yeah, I think that's the best I could, 190. See. 339 is the assembly one, by the way. I have increased the cycles. to have the similar numbers. Pentium 166. Of course, that's emulator. You don't know on the real thing. But we are comparing CPU. So 192. Okay, and I was keeping, if we don't unroll, hope I did it well. If we don't unroll, 152. Oh, that's good. That's better than here. I say 115 is the one from I might have it here. Demo Watcom. That's the Watcom version that I compiled before. I don't know if it goes unrolling or not. And here's the other thing now. Okay, actually, sorry, this is assembly 16-bit stos. Just to be fair, stos W. And I remember I was doing 299, almost 300, assembly 8-bit stos B. That's on the emulator though. In the real machine on the VGA directly it would be worse. So to be fair, this is the 16-bit version. That's why, comment that out, hopefully. That's why I say, okay, you know what? Let's not unroll first. Oh, what kind of version is that? See, it's a bit annoying. See, because I had to unroll, you couldn't see it. It's tedious to even work with that. So I'm calculating the first pixel, XOR the U and V's. I have to shift them. Then to add the DU/DV. I should have named them DU/DV, not PX and then do it again for the C1, and then VRAM16, which is a 16-bit pointer now. I'm just writing the 2 pixels. Alright. Is it an M? And now I'm not unrolling. And I say, now I'm doing 2 at once. But because it makes the code much worse, it does, yeah, that's what it did. It does 132. It does worse than the pure 8-bit, which the code goes simplified so the compiler. So I cannot recreate the STOS W version. So I said, okay, maybe you have to unroll it. Maybe you have to unroll it 160 times. It takes time now because there are too many C lines. So it just takes time. I see you cannot write. You write the more simplified version. It does some magic. I'm going to even show you what. You do the kinda more, and it's not much more. I say I can optimize. I have optimized that. Oh god, it takes forever. You just have to remember it was a Pentium 166. Pentium 166. That's done. Oh, what? No, we have to do it again! Hey guys, I enrolled 160 times and I kept the loop. That's ridiculous. And you don't even need that. Here we go again. And I hate how DJGPP, okay, it's an optimized compiler, it takes so much time. It takes so much time because it optimizes. And because I have unrolled it myself. Ah, fine. Just for 136. One was the other 132. It did minimal. Because I guess if you see the code, it's going to be a fucking mess. And it's always this. Oh, you should not go. You should not confuse the compiler. Let the unroll be like the. Yeah, but when I had the plasma effect, a simple unroll, a simple eight lines unroll, DJGP screwed it up. This is a simple. Sometimes you see performance and it's easy. Now this is more of a mess with unroll 160. But when you do 4 unrolls, there was a difference. You could have an effect that is 45 frames, 50 frames, and you cannot reach 60 frames. You might want to target 60 frames for one VBL. And just a little thing like that, someone would say, don't do that, the compiler will do it for you. No, it was so simple and it gave the performance. I hate these dogmas that some things you must not do them. It's forbidden anymore. It's deprecated. You should never even think about trying. While my philosophy in Optimize, one philosophy is try it. Count the difference. Count the performance. Okay. And I know some people said I prefer my code to be clean and be slow than dirty and fast and ugly. Okay, I'm going to write the less optimized. I'm not going to do at least such strict. I'm going to optimize at other place. Fair enough. I mean, I don't, I don't have a problem about how people write code. Although it seems like I argue all the time, but there is a general. Maybe some other people will come and tell me, hey, what you're doing is wrong, it's so unprofessional, it's so ugly, this is a thing of the past, you don't need to do it, the compilers do it for you, you know. So I need to, okay, this unroll, and why do I have an old unroll? And why don't I just comment that out? Because fuck this. Ugh. I have that. Oh, I'm gonna show you. Yeah, there might be. See, in Godbolt, when we unroll stuff, something failed, and when we didn't, was okay. Indeed, if you, there was, maybe we can see it in Godbolt, because, see, and you have all these compiler flags, okay. Oh, I don't have it here. I thought, and you might see help the compiler, but you might miss most of that stuff. If you write assembly, you will not miss that your code was junk. Maybe I can find it here. Yeah, we have this, there is this f unroll loops, there is the omit pointer, which I don't know, I need to read about that stuff. And most nerds know that stuff, and they might say, you don't know that stuff. And then you talk about optimize. Yeah, because these are gimmicks. I have the real philosophy of optimize, the real spirit. I once was asked in an interview, you say here that you like optimizing stuff, and have you used a profiler? And I was like, I rarely use a profiler. I used once. It's how do you know where to optimize? Because it's a simple effect and you see it. You don't need to look at your code and say, I don't know what to do. You just don't need to. So maybe we can see it with that. And it was interesting, I think it is. Now it did unroll. I have seen something more interesting. I think it unrolled it a few times. Okay, that's a regular unroll. Oh, I know. Okay, it unrolled it 4 times, which is fine. See, okay. Okay. It did the unroll thing. Interesting enough. Actually, we should be fair and try it. I don't know why I had removed it at the time. And this omit frame border, this is I have heard that a lot. I need to see what it is, but again, my point is that these are gimmicks. These are things that the programmer says. You have all this stuff, yeah, but it's so chaotic when it optimizes and when it's not. Okay, most people won't even see the generated. Most people will write blindly what they consider clean code and modern programming principle, and they would think if I do all of this, it's going to be magically fast. So let's see. I'm curious. It was faster now because. Oh, 164. 164. So that went 164 from 152. But previously we tried to unroll ourselves and we got more. But we unrolled everything and no loop anymore. If you combine, maybe you will confuse the compiler. If you combine, I think we will get one. So my unrolling did 192 in C. In C, not in assembly. In assembly it does 299 with the 8-bit and 339 with the 16-bit. And when you try the 16-bit thing, it falls to 136. It even fails. You do tricks like combining two pixels. I think this works better in ARM because they do the shift almost for free. All this shift and combine and OR, and you can do them in one instruction, two things in one instructions. Because I have seen when I was writing, I will show you my triangle rasterizer byte by byte. Then I made a version that it writes at the edges, it writes bytes, and in the middle it writes four bytes at once. And it gave a big, even with C compiled code. So when I do tricks like combine several pixels, maybe x86 screws it up, unless you do it yourself in assembly. And maybe ARM compilers do it better. And I don't know. And it's going to be, if you unroll this, it might confuse the compiler. Because we did, how much did we do? 165. After we remember to. Yesterday, in some other code, I have something more interesting. Here it's unrolling it 4 times. It does E6 plus 1 plus 2. Add E6 4. It starts from E6 minus 1 for some reason. In the increase, maybe it's for the loop or something. I'm not sure I get it. And of course, I do it better. A bit better. It's close. Okay, it's close to what I would do. But I've done it better. I've done it better because I'm smarter than the compiler. The compiler is a robot that makes gimmick. The compiler cannot think in higher levels of the human spirit. Okay. So I was gonna try it. I'm not sure if I want to. Because it's not because I'm afraid. I'm not afraid. Because it's gonna take ages. It will confuse the compiler. Confuse the compiler. So okay, I guess that gave it. Why? Again, why is it? Why am I that much faster with the assembly version? I do the exclusive OR thing. He's moving a AHDX and XOR them while I do it. But those are small instruction. Okay, I gained one small instruction that is no big deal. The other happening to register directly and just use the move. I use the stos. I could use the move. What the hell? I don't know which is faster. It depends on 386, 486. It depends on the CPU. So, and that just no, it unrolls. I mean, if you unroll 8 times, it unrolls 4 times. You will. Does this omit frame pointer do anything, by the way? No. I don't see why. Oh, hold on. No. I forget what I compare. This is the 16-bit. But my 8-bit was 299 when I tried it. So it's still way above. Maybe I mean, oh, hold on. The same comparison. Pentium 1666. Okay, it gave the same edge. 190, 192. So, so they say you don't need to unroll, compiler unrolls it for you. And you might say, I'm wondering if I should try this on the real machines. Especially in a Pentium 1. Okay, it went from 152 to 165 because it did 4 unrolls. But by unrolling the whole shit, okay, I got I think 299, and with unrolling the whole shit here manually, I got 190. So I still don't do the unroll. The compiler is doing it. I did the unroll in C, and I get better result. It's significant, okay. But of course, you end up with code that takes ages to compile. Yeah, and if you do it in Watcom, it's not nice because the inner thing is not optimized. So that's how you end to say, you know what, I'm going to write it myself, and I'm going to, and I need to find, maybe I'll do a preprocessor. I need to find how to, my beauty is this one. This is my beauty. How to say repeat that. You don't even have a macro for that, man. I could code a preprocessor. You might say, yeah, too much hassle, man. I don't know. I get it. People want to avoid to do what I do because I'm wasting my time while others producing software, even if it's not as fast. And yeah, maybe one more. No, it's hard to get it because the optimizer is doing weird things. No, so I had my 3D engine. I'm showing you something new. I don't remember where I stopped before because it took me time to find out, and I would. It's such a mess now to show. I had written in C, and I would do things. These are confusing. These are producing bad codes, and I was thinking of writing them in assembly because I'm going pixel by pixel and I'm rendering a byte, but then I have a 32-bit pointer. So now I calculate 4 pixels, and I do FU plus DU, FV plus DV. This is the rasterizer for the texture mapping. Okay, convert to fixed point, get the text data. I have the text height shift so that I don't multiply. It's a power of two textures, but I'm passing it. And I do this on, this is a central loop in the thick central blocks of the scan line, but outside XL is the left side X coordinate. If it was 0, 4, 8, it would be fine to go directly here. But if it's some leftover bytes that are not aligned with the 32-bit, I will have to tackle them individually. Use the 8-bit pointer to write them, and then I decrease the length, and then I go 4 by 4 pixels. I compose a big 32-bit. I have this endian because this is what I have on the ARM and on the NEC PCFX, and so I was porting this code here and there. So I'm interpolating 4 pixels and then blend them in one. Now I had tried the initial byte version when I was doing this on the 3DO, and this thing worked there. Maybe because the ARM with the shifts and all, it does more efficient, but maybe it's not as efficient. The reason, it's hard to explain. The reason it's not as efficient is that I isolated a lot of things. Led me to the horizontal rasterize. This is for the gross shader, no UV. You add the gradient of the color to the FC to the color. You get it back by fixed point. I think this is 12, the FP base, 12 bits. I don't know why it's not 16 bits, maybe because of precision issues. And I just tried it and it decreased that simple thing. No unroll, no 4 pixels at one. I think it ended up being faster, and forget about this assembly thing. And here now I isolated. That's not right, by the way. Oh my god. It used to be that this loop goes in. Here I go scan line by scan line. This count is the vertical. High, low in the screen, high in the screen. I get the edge from the edge list. I loop every scan line and then I call the horizontal raster line. This is how it used to be, but for reasons I wrote the whole thing in assembly. But anyway, what do I mean? It used the other runs are like this. This one is okay. This one is the horizontal raster line. It's much bigger with all this 32-bit. It's too big for the compiler, and I still call it here the environment map edges. I was doing this, but this one now, the Gurod environment map edges, it has the vertical loop and the horizontal inside. But when I isolated the horizontal, or even this loop inside that loop, so I could have taken both together, I noticed something. And here, of course, because the compiler optimized, if you pass regular number, I only had this function. No assembly to display. It doesn't compile because you don't call it. It's hard to see. And when I compile, okay, I had constant numbers and it did something else because it knew the numbers. So I just use the arcs randomly on the horizontal left and right edges, the color on the left, and so on. The length. Oh, I'm passing the this. Okay, this is the increment. I did some optimization. I'll show you. Anyway, but the interesting thing is this one now. It's unrolled. This is variable now. It's not like the Rotozoomer that is 320 lines or something, and it unrolls 4 pixels. This is, I think it created a what is called a Duff's device, maybe. This is depending on the first few bytes, if they are aligned or not in 8, I guess 8, not sure. It will jump at places here, and here it will write byte by byte, and then it will jump in this block, and this is unrolled like 8 times, I think. Yeah. And it has unrolled that with a variable length. Okay, that's pretty clever. And see also the registers. It uses a LEA. This looks like an address, but it's a LEA. It's a faster add to do this FC plus DC. That's pretty cool. It shifts it by 12. That's the FP base, and it writes it. It's as fast as you can think. Okay. And that makes me wonder, actually. And oh god. So it does something. It does something, but I decided to try to write some assembly. It's not even. I wanted to write the one where I write 4 pixels at once, because this one is still writing. It unrolls it, but it writes 1 pixel at once. That's bad for the VGA if you write directly. My current code is write directly. Maybe if I had a back buffer, that could be better, and we could finally say, even if I don't like it, in this case, but you have to search it. You have to play with with your code. You have to rearrange the code until you get the result. That's what I don't like. Okay, but you could have a rasterizer that you say it's better like this than if I wrote it in assembly. Okay, maybe. If the writes they are byte by byte writes, but at least if they were in a frame buffer. But now my version, I'm trying to, like here where I do for 4 variables and I complete it and write 32 bits at one, or even 16 bits at one. I could do a 16 bits at one. I think I have done a 16 bits at one for some reason. But combine the pixel and write one block. You still have to calculate pixel per pixel individually. This doesn't translate. I tried this one, and because of all these variables, it starts having ESPs. Read the variable from memory, write it, write. Read in the inner loop where you are trying to make everything with register. It starts to having ESPs a lot. And imagine what would happen if I interpolate the UV color and a lot of stuff. Because that's a minimal example where it's very simple. Of course the compiler will optimize it, and of course the compiler will do some very clever unrolling, but very mechanically. I don't like the mechanical. I like the coding spirit. So I tried very painstakingly. I tried to write an assembly, and my worst thing was there are not enough register on x86 man to avoid, and I managed to. I'm doing this where I write bytes, but it's a bit of a mess, and maybe I'm doing more stuff. But these are for the edges, and here is the skip to fill 32, and now I'm writing 16 bits because I had an issue, and that's fine. That's fine for the ISA. graphics card, and this is going to be much better for the 286. If I make a demo for the 286, maybe I'll go this approach, because on the 386, here is the thing. I have a fixed point 12, and so when I add EDH to EBH, this is like, says, this is the same. The Guru shaded pixel in 256 in VGA. But my Guru has a range from 0 to 15 anyway. But this one, because of the fixed point, the result will be, hold on, 12 bits. 8. The result will be here. And this sucks. And you know, yesterday I wanted, hold on a minute, sorry about that. Is it on math-util? I wanted to change this is the FP base, the core is for something else, to 8. But I'm not doing that. But it crashed, the whole thing crashed, even the C code crashed. Because something changed in the precision. And I'm going to do it for a 286 demo. Because on the 286 I will have to use 16-bit numbers, so my fixed point will have to be something like that. And this would fit perfectly here with the register. And because this is like this, I try to avoid having to do shifts, but then I get, and I have to shift because I need this part maybe. So I shift all of it 4, so it goes, and now I have it in the high byte. Do I need it in the high byte? Oh, hold on. It's even more silly than this. I need it in the low byte. I move AL and AH with the values. Man, I don't remember. It's ridiculous. It's shift 12, isn't it? And the next one would be, it will be here. And this don't matter because my Guru is from 0 to 15. It's minimized to use fewer colors at this point. Maybe I can make it more colors. So we don't care about this extra that are outside because you won't see them. So we shift 4. And we get this representation here. Ah, yeah, because I don't know why we do that, because we stos. I don't remember, man. Maybe I'm doing it wrong. I'm saying bullshit. I move the high. Oh god. No, I move the high. And it's even that. We don't even go 16 minutes. I move this to AL and then to AH. So you end up having this. Where 111 can be anything. It's like whatever value it is. And then I shift down. But here is the thing. I will call it Y. See, I have to do extra work because it's not 8-bit fixed point. This one is not 0. This one is like this one. This is fixed point. Yeah, it's you don't try to understand it. But the low fixed point values are overflowing here. So I have to move this on the side and end it at the end to clean up, else I get garbage. Okay. I might just have to not explain much here. It's a rough lamenting of my pain with the compiler and the assembler and my attempt to prove something. Now we can compare this. This slow, the 386 here slow, but okay. The Watcom, let's write so that you hear. The Watcom was, no, the DJGPP was not bad with the unroll. On real 386 dig, I'm going to write so because some people complain there are no subtitles at first. And it's important to conclude something. Actually, I tried the Watcom too. The Watcom did with this cube at this angle length, because if it rotates it changes. So I scaled it up. It's very close. It's much closer than my old tests. It did 35 frames. The DJGPP did 44 FPS. This assembly version did 48 FPS. So even if it's with a lot of pain, I managed to get a bit more. And also the reason is I'm doing stores W and I'm writing directly to video RAM. Because I think in the emulator I haven't seen much difference, I think. In the emulator I might have lost the bet. But on the real machine I won. And I did a dirty version that doesn't work. I did a dirty version where I would no, even with stores W, where I will not do that. I will not do that, which is the correction, and I would assume that it's 8-bit, that these are 8 bits. So you could do move AL bits, add ABH, move AZD, stos. I did such a dirty version, and which assumes if I change the 8-bit, then if I change to the 8.8 fixed point, and especially for a 286, maybe I'll write this on a 286. I will stop with the 386 for this one, and I will rewrite my engine for the 286, where it makes more sense to have the... I think I got 54 FPS from 44. So, yeah, you could rely on the DJGPP if you don't want to write assembly. But still, if you didn't do this breaking, here I do this. This is the C version. Forget about that. And this one I have it separately. Then it will optimize. As they say sometimes, if you break your functions, the compiler will find it easier to optimize and blah blah blah. That might be true. I don't know if you do the UV version. interpolate color, U and V, and a lot of stuff. If it would be the same, but I'm sure if I do the fill texture edges, rasterize or texture guru, I'm going to also have issues because there are not enough registers. I'm already doing in the outside. I'm popping stuff. Also, this is going every line. I'm pushing and popping some stuff, but it's on the outside, so I managed to somehow get the inside, but oh man. And yeah, it's a bit desperate. It's a bit. I get it why most people don't want to go there because there's a lot of pain and sometimes you might not see results. But we are okay. I'm going to tell you something else that is funny. We are working on retro. There was some discussion somewhere about the C compilers on CPC, on Amstrad CPC, on Z80, SDCC, and ZX80, ADK. And someone was, I don't know, suggesting that they remove Go2 because it's the eternal enemy. It must go to existing modern compiler. I mean, and there is this dogma. That's the other thing. You are coding for a retro machine. That's the other thing. Why would you come to say we have to follow modern programming standards? You are not even coding for a modern computer if you're coding for it. Why would you come in a retro C compiler say there is something we should fix. We should remove the Go2. Why? Why are you a maniac about Go2? It's an old thing nobody uses. No, it has its uses. I will make an episode on it. But why would you? It's like I go in 4chan and say we need to clean this toxic place and make it a better person. We need to make the milk toast 4chan. This is retro. Why am I doing this? Why am I doing this episode? Of course I'm going to write the unconventional stuff. Of course I'm going to. Because this is not even about optimize. This is not even about optimize. It's about the human spirit. This is not even about optimize. It's about the human spirit. I was going to rant more about it, but maybe I have to finish. And this is a bit of a different episode than that. I was going to not talk. I mean, that's for another episode. In order to optimize, to write the assembly, sometimes that the Guru shading in assembly, the rasterizer, I refactor the whole C project because previously I was doing much more work, and in this article first I read that you don't need to calculate your gradients. You need to calculate them per triangle, not per scan line. And I used to calculate them even in this engine. Before what I showed you previously, I used to calculate them per scan line, left, right, and I had a division table to avoid divisions. And there is a problem with that, though. I have to take it. I haven't taken it. I have some bugs and some crashes because you have to move your offset. It's pretty complicated. So that when you, I only save the color and the U and the V on the left side, and then I find the gradient by using. I just plug that here. I understand the explanation. And it worked. I wasn't even sure if I have to sort my points. I tried to use this with different points. So I call a function. Maybe I can show you. Is it here? So I did a lot of refactoring just to simplify myself writing the assembly later. So the Guro shader does not need to calculate it every scan line. It takes less arguments. And I have a new gradients thing. Now on the fill agents, I'm passing those gradients, but they are the gradients per for the whole triangle. Let me see. See, now I take the gradients and I read the grads DC outside. This is another problem I have with this. I need to see the assembly syntax, because if I wanted to take the DU, I would have to say that. But I don't know how I can say, I don't know, offset DU or something. So here with the edge, and that's why I have the comment. ESI plus 4, I get the right edge, the X right. Now I have to save the X on the left here and the X on the right, and the CL is in ESI plus 8. Because my struct, I have XL, XR, C, U, V in my struct, all of them in 32. So here when I'm passing the edge in the ESI, I'm just put magic number and I'm just saying, I need to see how, I don't know if this assembly you can do that. And even here, where is it? The human spirit. Oh god, oh my god. I'm adding 20, size of edge. Maybe there's some syntax that you can incorporate this in your assembly with the stack, so that I don't put the magic numbers, it's more safe. Because if I change the struct, if I change this struct or that struct somewhere in my code and add more stuff, these things would fail. But for now, comments are enough. So anyway, I wanted to, as a final thing, I refactor a lot of stuff, and this made other parts faster. When you render many polygons, it's a bit faster, like 2 frames faster from, let's say, from 36 to 38 frames, even without the assembly thing. Because I'm not doing much work per scan line, and even in the edges. Even in the edges, if you do this trick, here in this, from P0 to P2, you have to interpolate X coordinate, C coordinate, U, V coordinate, depending on what you need. But from P0 to P1 and P1 to P2, you don't have to interpolate anymore. You interpolate the right X edge, so that you know left and right X, and you know the length, and because you have the initial interpolars from P0 to P2 and you add the gradients. Okay, I should have done another video for that one in the future. Also, this is not some crazy optimization. It's a good optimization trick, but it was well known here. And so here I calculate the triangle gradient, and I only calculate if I need Guro or texture. If it's Guro shading and texture mapping together, both of them will be calculated. Now I have brought back the division. I will, even if it's per triangle, so it's minimal. So maybe it's fine with the divisions. But I have other issues. I need to check for division by 0. There are some pixels on the right, because you have to be sub-pixel correct on the center of your texel. There is more work to do to make it not fail in some cases. And I was afraid that, what is the order of the triangles I have to give? What if you give this, this, and this? Or what if your triangle rotates? Do you have to sort them? But no. This is, if you do that, it will work. You know, if you do that, it will work. And it will find the left to right scan line gradient. The way the equations are, the components that you pull in, it always finds the gradients correctly. And unfortunately, I have to solve these micro issues. This is a good optimization, but I have to be sure I'm on the center of the texel and offset a bit the interpolance base of how far I am from the center. There is more work, no, right? If I want to make a dirty rasterizer, I will reduce the for the 386 or 280. I will just not go very much to the edge of the interpolance. If I want to interpolate from 0 to 255, I will interpolate from 8 to 242. Let's say, so that if it goes a bit off, it will be okay. Especially with the texture lookup that I got crashes sometimes. So yeah, it was a wild trick, and I did that, as I said, because the C loop is much simpler. I used to here I used to calculate interpolance per scan line, and I had this division table, and that would be extra arguments to the assembly code. It would be even more of a mess. So I did the whole high level thing to make it easier to, and still it was a pain. I want to write this on the ARM, on the Archimedes at some point. Even though I'm thinking, because the ARM has more registers, the compiler might optimize it better for you. So you might have to resort to other optimizations on the ARM. And maybe it's better to stop, man. Maybe, and sorry, I was talking to a friend and we agree that maybe I should not drag it so long. If I talk about something and it's unnecessary stuff, I could go back and erase them. But now I haven't done this again because I wanted to get that out of my chest. And maybe it's silly because, you know, we are in modern times, and a lot of my projects, even in retro, they are in pure C. Because I wasn't a maniac about optimizing assembly. I was a maniac about the idea that you wouldn't, the compiler, not the compiler is your god, but if someone sees me writing assembly, they will be like, the compiler is an Einstein. If I put a pistol in your head and say you have to write this, you will still not be able to write what the compiler does, which is bullshit. It's bullshit because I can write things that tend to be faster than the compiler. I can engineer things, and this is a little thing. The Rotozoomer was, I got much better results for the Rotozoomer, but it was more brute force, the Rotozoomer. Some brute force things, the plasma and the fire, because it's just reading few memory addresses and that, yeah, the compiler does something that I would not be able to do better, so I have to resort into algorithmic tricks. Okay. And it depends, because if you do it on the Z80, with those tricks with the nearby unrolling and some things you can still get. It depends on the platform, it depends on the 32 bits. I do the 32-bit trick I show you, so you can recreate that with, so you can recreate some of the other tricks, and it's hard to explain. It's about the human spirit. And I get it. I'm not. Yeah, what I was going to say. I'm not writing everything in assembly. At sometimes I want to, as a sport or as a challenge, to say, can I make a faster one and how fast it can be? How can I push the 286? If I only relied in the compiler, even in a good compiler, okay. I guess I need to stop, and this is going to be as chaotic as it is. Maybe my next video will be smaller and I keep to the point. But this is half a rant and half a compiler and assembly exploration of various things. And that's it. Bye.